Rain is a natural phenomenon that occurs when water droplets fall from the Earth's atmosphere back to the ground. It is an essential part of the Earth's water cycle and is primarily caused by the condensation of water vapor in the atmosphere. When the sun heats the Earth's surface, it causes water to evaporate, transforming liquid water into water vapor. This water vaporizes into the atmosphere where it cools and condenses to form clouds. As the condensed water droplets in the clouds grow larger, they eventually become too heavy to stay aloft and they fall back to the Earth as raindrops. Several factors contribute to the formation of rain. One of the key factors is moisture in the air. When the air is sufficiently humid, water vapor can condense around tiny particles such as dust, pollen, or pollutants, forming cloud droplets. Another factor is the presence of a lifting mechanism. When air rises and cools, it can trigger condensation and cloud formation. This lifting mechanism can occur due to various natural processes like convection, frontal systems, orographic lifting when air is forced up and over mountains, or convergence when air masses collide. Once the cloud droplets have grown to a size that gravity overcomes the upward force of air, they fall from the clouds as precipitation. This precipitation can take various forms depending on the temperature, such as rain, snow, sleet, or hail. The amount of rainfall can vary depending on several factors, including the geographic location, prevailing weather patterns, temperature, and topography of the area. Different regions experience different levels of rainfall throughout the year, leading to variations in the distribution and availability of water resources. Overall, rain plays a crucial role in maintaining the Earth's climate and ecosystems. It replenishes water sources, supports plant growth, and sustains various forms of life on our planet. There are different types of rain that occur under specific conditions. Some examples include: 1. Convective rainfall. This type of rain is usually associated with thunderstorms. It occurs when warm moist air rises rapidly, creating intense updrafts. As the air rises, it cools and condenses, forming cumulonimbus clouds that can produce heavy rainfall with thunder and lightning. 2. Frontal rainfall. This type of rain occurs along the boundaries between two air masses with different temperatures. When a warm air mass meets a cold air mass, the warmer air is forced to rise over the cooler air. As the warm air rises and cools, it releases moisture, resulting in persistent rainfall along the front. 3. Orographic rainfall. Orographic or relief rainfall occurs when moist air is forced to rise up and over elevated landforms, such as mountains. As the air rises, it cools and condenses, producing rainfall on the windward side of the mountain. The leeward side, on the other hand, often experiences a rain shadow effect with drier conditions. 4. Convectional rainfall. This type of rain is common in tropical regions, where intense solar heating causes air to rise rapidly, forming thunderstorms. The rising air cools, leading to the development of cumulus clouds that produce heavy rainfall in relatively short periods. It's worth noting that rain is not always beneficial. Excessive rainfall can lead to flooding, landslides, and other destructive consequences. Conversely, regions experiencing prolonged periods of drought may suffer from water scarcity and agricultural difficulties. Understanding the causes and patterns of rainfall is important for various reasons, including agriculture, water resource management, and climate prediction. Meteorologists and scientists study these processes to enhance our understanding of the Earth's climate system and improve weather forecasting techniques.
Hey there, if you're finding this content interesting and engaging, why not show your support and give me a like? It helps me know that I'm creating content that resonates with you. And while you're at it, consider subscribing to the channel as well. By subscribing, you'll never miss any future updates and you'll be part of this amazing community. Thank you for your support.